Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this word problem using the concepts of derivatives. So as per the problem, a train leaves the station at 10 a.m. and travels due south at a speed of 60 kilometers per hour. Another train has been heading due west at 45 kilometers per hour and reaches the same station at 11 a.m. And we have to find at what time were the two trains closest together. So the first step here is to draw a diagram for this problem to understand what's happening in this situation. So there is a train that leaves the station at 10 a.m. So let's assume this is the station S, and there's a train that's traveling south at a speed of 60 kilometers per hour and leaves at 10 a.m. So the time at when it leaves is 10 a.m. Another train has been heading due west at 45 kilometers per hour and reaches the same station at 11 a.m. So at 10 a.m. there's another train here and it's traveling due west towards the same station. So this train is traveling at a speed of 45 kilometers per hour. Now the second train reaches the same station at 11 a.m. That means from 10 to 11 a.m. it covers the distance from this point to this point, the station S, in 1 hour. So that means the distance of the second train from the station at 10 a.m. was 45 kilometers, because in 1 hour this train will cover 45 kilometers because its speed is 45 kilometers per hour. So at 10 a.m. this train, the second train, was 45 kilometers to the east of station S. So this is a very important concept we need to understand about this problem. Now we have to find at what time were the two trains closest together. So that time will be somewhere between 10 a.m. and 11 a.m. because once the second train reaches the station at 11 a.m., the other train will keep going farther away from that second train because the second train would have reached the station which is directly to the north of the other train, the first train. So that means we have to use a variable for time here, and time should be greater than equal to 0 and less than equal to 1 in hours. So the trains will be closest to each other anytime between 0 hours, which is at 10 a.m., or between 1 hour from 10 a.m. So let's assume the two trains are closest together t hours after 10 a.m. So that means that the train going south would have traveled this distance, some distance in the south direction from station S. So I'm drawing a second diagram. So this is station S, and the first train would have traveled a distance of 60 t. So for this, I'm using the formula for distance. So we know that distance equals speed times time. And the speed of the first train is 60, and we are assuming that after t hours from 10 a.m. the trains will be closest together. So in those t hours, this train going south would have traveled 60 t kilometers in the south direction. Now the other train, the second train, would have traveled 45 t kilometers. So that means the distance of that second train from the station after t hours would be 45 minus 45t. because the other train is 45 kilometers away from station S. So in T hours, it would travel 45 T kilometers. So its distance from station S after T hours will be 45 minus 45 T. So there's another important concept we need to understand about this problem. In the case of first train, since it was moving away from that station, so we didn't have to do any subtraction. But the second train was already some distance away from station S and moving towards it. So that's why in order to find its distance from the station after time t, we have to subtract 45t. So 45 is the speed of that train from 45, because 45 represented the distance of that second train at 10 a.m. from station S. So the train, the first train was at point A after T hours, and the second train was at point B after T hours, and the distance between these two trains will be this third side in this triangle. And this is a right angle triangle because the west direction and south direction are perpendicular to each other. So now we can use an expression for the length of this side AB in this right angle triangle, and for that we can use the Pythagorean theorem. So let's assume the distance from A to B at time t hours after 10 a.m. is distance d. So we can use Pythagorean theorem. So as per the Pythagorean theorem, so if you remember, so c square equals a square plus b square. So c represents the length of the hypotenuse. In this case, it's d. So d square equals, so a can be 60t. So 60t square plus 45 minus 45t, and then square. Now we can simplify this expression. So we can move here. So d square equals, so 60 square is equal to 3600 t square plus, and then 45 minus 45 t square. Now we can change d square to d by applying square root to both sides. So we get d equals square root of 3600 t square plus 45 minus 45. Now we have to find the time at which the two trains were closest together. So we are looking for a minimum value of d. So for that we have to find the t values at which the tangent is horizontal to this function d. So that means we are looking for the valleys in the graph of function d, because we are looking for the time when the trains were closest together. So for that we'll have to find the derivative of d and then set it equal to 0, because the derivative represents the slope of the tangent. So the first step here is to change the radical to a rational exponent, because that will make it easy to find the derivative of this function. So 3600 t squared plus 45 minus 45 t squared, and then exponent half. Now we can use chain rule to find its derivative. So as per the chain rule, we have to find the derivative of the outer function first times the derivative of the inner function. So the outer function is the exponential function with exponent half. So we'll have to use the power rule for the outer function. So the exponent half will move to the front and will subtract 1 from it. Plus 45 minus 45t half minus 1 in the exponent times the derivative of the inner function. And the inner function is this polynomial function 3600 t squared plus parentheses 45 minus 45t parentheses square. So we'll start with the derivative of the first term 3600 t squared. So 3600 is the coefficient, so it will stay the same, and the derivative of t square is 2t, and then plus now the derivative of the second term. So we'll have to use chain rule again because there is an inner function 45 minus 45t and the outer function is the exponential function with the exponent 2. So we start with the derivative of the outer function, and for that we'll have to use the power rule. So we'll move the 2 to the front of the term, and then 45 minus 45t, and then exponent 2 minus 1 times the derivative of the inner function. So 45 is a constant, so the derivative of 0 minus 45. The derivative of 45t is just 45. So this should be the derivative of this d function. Now we have to simplify this expression. So in the first part, so the first parentheses will have a negative exponent. So half minus 1 is negative half. So we can move that to the denominator to make the exponent positive. So we can start with the second part. So 3600 times 2 is 7200. So we get 7200 t, and then 0 minus 45 is negative 45, and times 2 will be negative 90 times 45 minus 45t, and the exponent is 2 minus 1, which is just 1, so we don't write 1 as an exponent, over 2, and then the expression with the exponent half. So the negative half will change to positive half in the denominator. T square and then exponent half. Now we have to find the t values where the tangent is horizontal. So we should sub in the derivative as equal to 0. So we get 0 equals. Now we can simplify the numerator. In the numerator we can distribute the 90 into the parentheses. So we get 7200 t, and then we do 90 times 45, which is equal to 4050. So we get negative 4050, and then plus 4050 t over the expression in the denominator is the same. So 360 t square plus 45 minus 45t square, and then exponent 1 over 2. Now we can solve for t by cross multiplying the denominator. So any expression multiplied by 0 will just be equal to 0. So we can just continue here. So we get 0 equals, so 7200 t minus 4050 plus 4050 t. Now we can move this number term to the left side of the equation and combine the t terms on the right side of the equation. So we add 4050 to both sides. So 4050 on the right side will cancel each other out. So we get 4050 equals, so 7200 plus 4050, which is equal to 11,250 t. Now we can divide both sides by 11,250. So now 11,250 on the right side will cancel each other out. And now we can do the division on the left side. So 4050 divided by 11,250 is equal to 0.36. So we get T equals 0.36 and the unit is hours. So this is the T value at which the slope of the tangent is equal to 0. Now we have to use three T values, the T as 0, T equals 0.6 and T equals 1 to find at which of these times the distance between the two trains is lowest or minimum, or the trains are closest to each other. So for that we'll use this distance equation we got. So I'll write it again. So the D equals 3600 T squared plus then 45 minus 45t square under the square root. So let's start with t equals 0, the lower limit of the interval. So d at 0, so we'll sub in t as 0 in this equation. So we get 3600 times 0 squared plus 45 minus 45 times 0 squared. Now in this case, so 3600 times 0 square will just be 0. So we get square root of 0 plus, now 45 times 0 is 0. So we are left with 45 square, which is equal to just 45 kilometers. Because the square and the square root. So that's the distance between the trains at t equals 0. Now we can do the calculation for t equals 0.36. So we can do the calculation. D at 0.36 will equal to, so 3600 times 0.36 square and then plus, so 45 minus 45 times 0.36 and then square, and we'll put this whole expression under the square root. Now we have to simplify this expression. So d at 0.36 equals, so first we have to do, so here also, so 3600 times 0.36 square, which is equal to 466.56, and then plus, now we have to do 45 minus 45 times 0.36, which is 28.8, and then we square the result and get 829.44 under the square root. And now we can add these numbers and apply the square root. So 466.56 plus 829.44, which is equal to 1296, and the square root of 1296 is 36, and the unit is kilometers. Now we have to find the distance between the trains at t equals 1. So d at 1 will be equal to, so 3600 times 1 square plus 45 minus 45 times 1 square under the square root. So d at 1 equals, so 3600 times 1 square is just 3600, and then plus, so 45 times 1 is 45, and 45 minus 45 will be equal to 0, so 0 square. So this is equal to just 3600 square, 3600 under the square root, and the square root of 3600 is 60. So these are the distances between the two trains at these three t values. Now, as per these results, the trains were closest to each other at 0.336 hours from 10 a.m. because at that time the distance between them was 36 kilometers, which is the closest distance. Now we have to find at what time. So that means we have to first convert the 0.36 hours to minutes, because we know the time will be somewhere between 10 and 11 a.m. And for that, we'll multiply 0.36 by 60 to convert hours to minutes. And I got 21.6 minutes. Now we can also convert 0.6 minutes to seconds. So that will be 21 minutes, and we'll do 0.6. So I'll do the calculation on the side. So 21.6 minutes is equal to 21 minutes. So 21 minutes plus 0.6 times 60. So that will give us the answer in seconds. So 0.6 times 60 is equal to 36. So that means 21 minutes and 36 seconds. So the time will be 10, 21 minutes and 36 seconds. So that's the time when the trains will be closest to each other. Now here we don't have to find what that closest distance is, but we got that in our calculation that the closest distance will be 36 kilometers. So this should be the final answer for this problem. So for this type of problem, it's very important to draw a diagram and understand what's happening in this problem. How are the two trains moving relative to each other, and what will represent the distance between the two trains. So for that we need to draw two diagrams, first to understand the given situation, and then the second diagram for the triangle that we can use to find the distance between the trains at any time t, and then use that triangle to find the equation for the distance. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.